Okay, we're going to start doing some more radioactivity videos, but before we do that, we have to discuss isotopes, because radioactivity involves isotopes. Well, what is an isotope? Isotope is an element that has a different number of neutrons than normal. And there can sometimes be quite a variety of different isotopes for a particular element. All of the isotopes in that element will have the same number of protons, always, because an element is always defined by its number of protons. So, for instance, carbon always has 6 protons. But some elements can vary in their number of neutrons, which means the mass of one carbon isn't necessarily the mass of another isotope of that carbon. So there's variation in mass, and that gives us different isotopes based on how many neutrons there are. So let's take a look at how we write about isotopes. This is notation for isotopes. As you can see, we have the symbol here, U, which gives us uranium. And the atomic number, if we look on our periodic table of uranium, is 92 protons, and that goes down here. So the atomic number is always the lower number in this isotope notation. The mass number is always protons plus neutrons, and so that will go in the upper corner. Now this is uranium-235. There are other uranium. There's uranium-238, and there are others even beyond that. So if they have different number of neutrons, they'll be different isotopes with different masses. Now this particular one has 143 neutrons. 143 plus 92, that gives us our 235. But it can vary. This is how we would indicate that we're talking about this specific isotope of uranium. Uranium with 92 protons and this specific mass depending on how many neutrons it has. Well, let's take a look at another example. This is our, we're going to talk about carbon. And so we have 3 isotopes of carbon here. We've got all 3 of them are carbon, so they use the same symbol. All 3, because they're carbon, have 6 protons, so they have the same atomic number down here. But we can have carbon with 12. We can have carbon with 13. Can have carbon with 14. Now over here, they have an illustration of different hydrogen isotopes. This is not isotope notation, but just a depiction of the nucleus. You can see right here, this is our ordinary hydrogen with 1 proton and no neutron. Now, there's an isotope of hydrogen where you add 1 neutron, and they call that deuterium. So this has a mass of 2, even though we're still talking about hydrogen. And then there's tritium, which has 2 neutrons. So this one would have a mass of 3, even though it's still hydrogen, because each of these have 1 proton, so they're all hydrogen, even if they have different masses. And lastly, we've got another example, cesium. Cesium has 55 protons, so we've got our symbol CS, 55, and it has a mass of, this particular isotope has a mass of 136. And what this illustrates is how we name it. Well, if we have different carbons, how do we distinguish them? We use the mass to distinguish them. So we would call this particular isotope cesium-136. That would be this one. If we use this language back here, we've got carbon-12, carbon-13, and carbon-14. So you understand what an isotope is. Same element with a different number of neutrons, so it has a different mass. We understand the notation of how to draw it. We've got the symbol, protons down here, neutrons up there, and we know the name is named after its mass, carbon-12, carbon-13, carbon-14. I hope this helps. Struggle well.